background data, in particular about weather data and GPS data. So why are we interested in such data? So regarding the weather data, we're interested in having data from different sources and compare how locally observed changes related to climate change agree or disagree with measured data from weather station. As mentioned before, it is not about like evaluating one is more correct than the others, but to complement, to see both data as equally valid, that complement each other and improve, to have a whole picture of the situation. The other type of background data we are asked you to collect are GPS data. So one reason is you see this like global map. So the LICCI approach is a global approach that like tries to find methods how we can compare different case studies that are distributed among the globe. So one idea is to have a final map with all the case studies and locations, and to see how well they're distributed about the globe and in which climate zones they are situated. And the third main reason is to understand the context, the local context of the field site. So, for example, to understand if there are protected areas in close by, or if the field site is located within a protected area, and to understand how, like, which area your data is representative for, if it's like a small area or a bigger one. Talking about the weather data, what we are interested in is our time series that cover a period of at least the last 20 years. So starting in 2000, the longer the better. So, but we have some very remote areas, so sometimes it's difficult to get weather data. In Europe, it's probably easier. Important is that the time series are complete, and they might have, or they can have some missing data, but they should really be like the exception. Otherwise, the data analysis does not work well. We want a temporary resolution of at least monthly data or daily data. This is both fine for us. And most important are temperature and precipitation data. But if you're able to get some additional data like wind or data about air moisture, even better, especially if like you're working in a region where wind seems to be very important. Then of course it is very good to have like climate data on that as well. So so to sum up, we are interested in time series, at least for the last 20 years of climate data, at least of temperature and precipitation, monthly or daily resolution, and for the nearest weather station. And we put kind of a big radius, like at least within radius of 200 kilometers. Better is, of course, the closest, the better. And what is important, not only the distance, but also that the weather station is situated in a location that is similar to your field site. So make sure that the weather data can be representative for your field site as well. if you're working in the high mountains and you know that the weather station is in the plain area, then this might, then this match will probably just due to the different conditions. And to get the data, this is a bit up to your creativity or experience, but and depends on the country and the local context, but some ideas we can give is there might be a national or there might be regional meteorological services stations. You can always also ask at airports, because they normally have some climate data. And if you're you can also try to contact research institutes or universities. So they might collect data themselves, or they may have an idea who to contact and who to ask. Yeah, in general, try the best that you can. We ask you to submit the raw data. This is not, we will not work further on the raw data, but this is kind of, if we find strange numbers, we can go back to the raw data and to check if there was just a error in copying the data or not. What we're gonna work with is a Excel sheet. So we ask all the partners to submit the data in the same format, and I will shortly explain how this looks like. So this is gonna make the analysis far easier if we have the data all in the same format. So this is a bit how it looks like. So the first sheet is the metadata. So we ask you to enter the information here about which data is available. So this is the daily maximum temperature, for example. So if you have this data, you put a 1. If you don't have it, you put a 0, 0, or you let it empty. That's fine as well. So important is that you put the 1 for the climate parameters that you have. So if you have daily precipitation, you put it here. If you only have monthly data, you put it here, the 1. And then there are different columns. So one is when you ask for the data. So yeah, this is kind of side information. The other one is the first. So this is important when the time series starts. The first entry, the date, and the last entry, the date of the last entry. And then the number of missing values. So then you can easily see if it's worth to analyze this data series or not. The name of this weather station, as reference, and the position. Here's the longitude, latitude, and elevation. And the last one is more information about the weather station when they start working. If you get the information, you can add it. If not, this is, let's say, kind of extra information. Then you see that for each climate parameter you have, there's an extra sheet. I'll shortly show it. So we want to have the data all separated. So this is currently one column for the date, and if it's daily data, then it's day, month, year. Well, for 2015, you put the whole year. And the temperature, the mean temperature in degrees Celsius. And please use dots as separator. And if you have monthly data, it looks the same, and you use the sheet for the monthly data, and then you don't have the daily amounts. That's it principally. Coming to the GPS data, so we have already produced 2 global maps, but those are not our field sites, but field sites from the literature. So there have been done other work on LICCIs and LICCIs, let's say. And some of the papers cover both topics, asking people our approach, what they have observed and how they respond to the changes they have observed. So both data sets are still not like complete, but like the LICCI database we have produced are only missing the last 2 years, and the LICCI like this has only contains entries for the last 5 years. So we're still working. It's an ongoing process. But what you can see is like that there are like some clusters in some regions. So for example, the Himalayan seems very well studied, like for both LICCI and LICCI. Then there are areas on the African continent, especially in the East Coast, and so around like Ghana and Burkina Faso, there has been done some studies, and in the Arctic, like Alaska and northern Canada, there has been done some studies as well. But then there are like areas which are very like less studies, so like the Sahara or the Middle East. Australia seems to be like understudied. So we are now trying with the LICCI to cover some of the missing areas as well. And then in the end, we want to have a similar map with the case studies that are globally, that are comparable because they all follow the same methods. Because here you see like different studies and everybody used different methods. And this is something we want to overcome a bit. So the GPS data we are asking you to collect is on the site level. So as mentioned before, the position of the weather station, the position of the closest airport, the position of the closest port. David will talk about this later as well. So, but in theory, it's about like to understand the connectivity of the field site, because some of our field sites are very remote. Then the area for which your data is representative. So this is a bit up to your evaluation or your understanding, but this is to understand if the data you have collected represent a very small area or quite a big area due to like similar conditions. Then GPS data on protected areas, and in the case if there's like an officially recognized status of the territory as belonging to indigenous and local communities, we're interested in this area as well, in this information as well. So of course, like there are different ways to collect the data, or some data like this about national parks, maybe you find the information also on the internet. In general, of course, the best thing is to get them in the field side, but this also depends on what experience you have and what like device, if you have a GPS device or not. So there are also like other options to get the data like from home. And so for example, like with Google Maps, you can always get the coordinates. Then there are like 2 web pages here where you can get the elevation. So I assume that not everybody of you has a GPS device, and I will show you like some examples of what you can use. So some might use a GPS device, some might know like QuantumGIS or ArcGIS and can like use those programs as well. Then they like Google Earth, Google Maps Altitude Finder. And then there's one which is called Offline Maps app, and we have focused a bit on that because the good thing is everybody with a smartphone with an Android system can download this map, and so most of the people probably can use it without like having to buy some new stuff. And so we prepared a LICCI technical manual where we explained in details how to use this application. As well, we have like prepared some tutorial videos like explaining each step how to get the data. But we are like quite, let's say, open how you finally collect the GPS data, but we have like put some restrictions, and because we cannot like accept like whatever kind of data, because otherwise we're gonna get crazy with it. So as we want to do like the analysis in quantum GIS, we need data in the format that is accepted by quantum GIS. One of them is like GPX data. So this will be normally the data type you get when you use a GPS device or when you use these offline maps. But we also accept like GIS features like shapefiles, or for points like a normal Excel sheet. So we have prepared one. So this is a CSV file, and then you put the name, like whatever you like, this national park, whatever, and the longitude and the latitude and the elevation. Well, of course not the national park, but because this is for points, but like the name of the harbor, like the port, and the name of, and then the dates and elevation. Of course, the better you know your field site, the better you can get the data from home. If you're not very familiar with your field site, it's better to get the data while you're in the field site.